So a very warm welcome to all of you guys. So today this video will going to be the last video from the microscopy lecture series, where we have talked about all the things that is included in our syllabus, and another video I will record extra that will be of scanning tunneling microscopy, but it will be later on. So today is the last video according to our syllabus. Okay, so today I will going to discuss about a mathematical problem from microscopy that you need to do before your exam, and I will also talk about some suggestions that you should do for your exam. Okay, so let's talk about the mathematical problems first. So remember, first thing, that as bright field microscopy is our in syllabus, where we are using the visible light source for the illumination, it is necessary to remember about the range of the wavelengths of all the visible lights. Okay, UV is 280 nanometer. It is also important for from the spectroscopy perspective, so I have also mentioned here. And then the VGO. Okay, so here I have mentioned all the important ones. So I think you know that VGO is this one. A I is missing because indigo is not necessary for us, and instead of indigo, in between B and G, you have to add another one, that is cyano. Okay, so the wavelength for VGO is 400. Actually, what is, if you remember, if you can remember this sequence, and then please add 50 50 50 for each subsequent colors. That means you start V with 400, then add 50, 450, add 50 again, then cyano will be for 500, then add 50 again, 550, add 50 again, 600, add 50 again, orange 650, and the last one, that is 700. So that's how you can easily understand or remember about the wavelengths of the visible lights. Okay, so here the important mathematical question that is mainly coming from the resolution. So we have already discussed about the mathematical formula of resolution, that is lambda by 2na, that is wavelength by 2 into numerical aperture. And numerical aperture, we can also write numerical aperture as small n sin theta, right? Theta is the half of the aperture angle. Okay, and small n is our refractive index. Refractive index is 1 for dry air, and 1.33 for pure water, and 1.56 for oil. That is we are using in case of oil immersion, right? And this is the formula for limit of resolution, that is small r. You can also use 0.61 alpha when it is mentioned that Rayleigh criteria is followed. Okay, otherwise please go for this one. Okay, so now we are ready to discuss about the mathematical problem that I have bring for you. Okay, so what will be the limit of resolution of microscope in oil and in dry condition if the half aperture angle of light of 600 nanometer? So 600 nanometer means here we are using yellow color, right? So they often can mention you that they are using yellow color or red color. Then from that perspective you have to remember about the wavelengths. Okay, so that they will help you to find out the wavelengths. Okay, that means instead of mentioning the wavelength, they can also mention the color. So it is necessary for you to understand or to remember about the wavelengths of the all the color, then you can easily find out what is the wavelength. Okay, and this is the aperture angle theta. So what we have according to the limit of resolution, 0.5 lambda to n sin theta. So here we are using n sin theta instead of numerical aperture, because they have mentioned theta. Okay, okay, so theta is 55 degree, and we have also the value for lambda, that is 600 nanometer. So we need n to find out the limit of resolution, right? And for that, please try to focus that in the question they mentioned dry condition. So I have already told you that for dry condition the refractive index will be 1. So your value will be this one. Okay, and now by simply solving that you will get this answer. Okay, similarly in case of oil, all the things will be same as compared to the dry, only the small n will be changed. So n here will be 1.53. okay, that will give you this result. Okay, you can also use this as a 1.56. okay, instead of 1.53 use 1.56. that is the actual refractive index for oil. So that is the one type of question. So a microscope have limit of resolution of 0.326 micrometer. Micrometer means 10 to the power minus 6 meter, right? So this is the value of small r at green light. Look, they have mentioned the term green light. So Vib Geor. So here in between B and G there will be C. So 400 for V, 450 for B, 500 for C, and 550 for G. So our wavelength here will be 550 nanometer. Okay, what will be the numerical aperture of that microscope? That means here we will take the formula R is equal to 0.5 lambda Na, right? So by simply putting all the things that we have 0.326. I will recommend you to convert it into meter, then it will be helpful to you. And also to convert 550 nanometer into 550 into 10 to the power minus 9 meter, and then solve the equation, you will get the value of numerical aperture. So I have also done this here. Okay, and I have get the answer 57.51 degree. Okay, 57.51 degree. Okay, so that is the two kind of mathematical question that they can ask from microscope. Now let's talk about the important question. Okay, so the first important thing that you need to know, that is why magnification is not enough, why resolution is important. That is the important question that you can get in your exam. Another important one is, what do you mean by empty magnification? That is, the magnification without resolution are called empty magnification. Okay, they can also ask you what is the difference between magnification, what is the difference between microscopy and magnifying glass. So microscopy will give you magnification along with resolution, but magnifying glass will only give you magnification. Okay, important. And they can also give you definitions like numerical aperture, resolution power, the limit of the resolution. That is nothing new. Then let's come to talk about bright field microscopy. Here an important question is why we need to stain the biological samples. Okay, I have explained this in the bright field microscopy lecture video. So if you want to know this, then please go and watch the video, you can understand. Now let's come to the dark field microscopy. So in dark field microscopy, they can ask you about the advantages and disadvantages. So what was the disadvantage of dark field microscopy? That is, yes, that is no doubt that they have provided the way, or they have provided us the opportunity to visualize specimen live, no doubt about this. But here we are using a low amount of light, right? So it is very difficult to distinguish between what is my cell and what is the artifacts. Okay, so then the important thing is phase contrast microscopy principle, very important. So how we are converting the differences in phase into a visible contrast. Phase contrast microscopy, it is important to understand the advantages and disadvantages of phase contrast microscopy. Okay, so that is the three important question from phase contrast microscopy, that phase contrast microscopy's principle, okay, is very important, and along with the advantages that it provides. Okay, now let's come to the discussion of fluorescence microscopy. So they will talk about some fluorescence stain. They can ask you in what cases you use FITC, or in what cases you use DAPI. Okay, that is especially for DNA staining. Okay, then they can also ask you about the principle of epifluorescence microscopy. Instead of asking epifluorescence microscopy principle, they can told you to write a difference between epifluorescence microscopy and transmission fluorescence microscopy. Okay, so that is all about fluorescence microscopy. Then let's come to the confocal microscopy. So confocal microscopy have solved the major disadvantages of fluorescence microscopy. They can ask you MCQ that confocal microscopy is the only type of bright field microscopy that allowing us to visualize 3D images. Okay, and here also the principle is important. Then let's come to electron microscopy. The first question they can ask from electron microscopy is why electron we are using for visualization purpose, or why we are using electron for the illumination. Why? Because electron are having shorter wavelength, and if we use higher velocity electron, so they will provide a more shorter wavelength, that is helping us to get a good resolution. Okay, then another question that they can ask, that is very very important and one of my favorite one, that is the difference between SEM versus STEM. Scanning electron microscopy, transmission electron microscopy. Okay, they can also ask you how scanning electron microscopy generates 3D image. Okay, so that is all about the things that they can ask you from electron microscopy. And the last thing, that is we have talked about the chromatic aberration and spherical aberration. They can also ask you about the definition of chromatic aberration and spherical aberration. So that is all kind of important question that you may face from microscopy part. Okay, so that is the end of this video. So I hope this video will be helpful for you. Thank you.